Hello and welcome back to Calculus Explained. Today we are looking at continuity and the Intermediate Value Theorem. So far we've talked about limits. Now we are going to ask a deeper question. When does a function behave nicely enough for calculus to work? That idea is called continuity, and it's the bridge between limits and derivatives. So continuity explains why we can differentiate and integrate functions, and many calculus theorems assume continuity. But what does continuity mean? A function is continuous at point x equals a if three conditions are met. 1. F of a exists. 2. The limit of x to a of f of x exists. And 3. The limit of x to a of f of x must equal f of a. Now the third one, it should seem like it goes without saying if the first two are true. But let me show an example of when the first two are true, but the third one is not true. Let's say we have a function, and it has a hole right here, but that point is defined here. So we say that if this is x equals 3, this is x equals 1, this is y equals 3, then we say f of 3 equals 3. However, the limit of x to 3 of f of x equals 1. These are not equal, so therefore the function is not continuous. Basically, if any of these three conditions fail, then the function will not be continuous at that point. Graphically, continuity means that you can draw the graph without lifting your pencil. You can see for this function here, I did have to lift my pencil to draw that hole and that point up there. That means that the function is not continuous. So in the video Introduction to Limits, we covered different types of discontinuities. One is removable discontinuity. For example, if we have function here, then you have this hole. That would be removable discontinuity. Now, jump discontinuity would be when left and right hand limits exist but are not equal. So if we have something like this, then you can see that the function randomly jumps up right there. That would be jump discontinuity. So if the left and right hand limits don't agree, the limit and continuity fail. The last one is infinite discontinuity. This is when you have a vertical asymptote, such as this. Because of this vertical asymptote, the function will blow up as it approaches that x value. That means that there's infinite discontinuity. So, to check continuity, let's look at an example of when a function is always continuous. For example, when you have a polynomial, let's say x cubed minus 2x plus 1, it won't always be continuous. You can put in any value for x, and it will give you a defined value for f of x. So polynomials are continuous everywhere. However, let's say a rational function is equal to f of x, such as x plus 2 over x minus 1. This is continuous everywhere except where the denominator is 0, or at x equals 1. This is infinite discontinuity. Now let's look at a piecewise function. We'll say that f of x equals x squared for x is less than 0, and 3 for x is greater than or equal to 0. This would look like this. For x is less than 0, you have x squared, but then for x is greater than or equal to 0, you have 3. This would not be continuous. It would be jump discontinuity. Now, I will introduce a concept called the Intermediate Value Theorem. Intermediate Value Theorem, or rather, IVT. So what is the Intermediate Value Theorem? If a function is continuous on a closed interval AB, continuous on AB, then that means for any value n between f of a and f of b, there exists a c such that f of c equals n. So for any value n between f of a and f of b, there exists a c such that f of c equals n. Now what is this actually saying? This means that if a function is continuous on that closed interval, then it takes on every value between f of a and f of b. So this means that if you were to walk continuously from one height to another, you must pass through every height in between. Now let's look at an application example. Let's say f of x equals x cubed minus x minus 1. We evaluate f of 1 equals negative 1, and f of 2 equals 5. Now this function is continuous because it's a polynomial, but you can see that the values switch sign. It goes from negative to positive. Now what does this mean? This means that there must be some number between 1 and 2 where f of x equals 0. This guarantees that there exists a point between f of 1 or between 1 and 2 such that such that f of x has a root at that point. It doesn't actually give you the location, but it tells you that it exists. Now let's look at some practice problems. 1. Identify the type of discontinuity for f of x equals x squared minus 4 over x minus 2. Now number 2. Is this function continuous at x equals 0? F of x equals x squared for x is less than 0, and x cubed plus 1 for x is greater than or equals to 0. Continuous at x equals 0. Now number 3. Use the intermediate value theorem to show x cubed plus x minus 1 equals 0 has a solution between x equals 0 and x equals 1. So pause the video, try these on your own, and when you're ready, we'll go through them together. Welcome back. So here we identify the type of discontinuity. You can see that you can factor to x plus 2, x minus 2 over x minus 2, and you get x plus 2, x cannot equal 2. This means that there is a hole at x equals 2, so removable discontinuity. Now for number 2, we are looking at whether the function is continuous at x equals 0. So we find the left and right hand limits. So from the positive side, it's x cubed plus 1. Now, when we go from the positive side, you can just plug in 0, and you get 1. From the negative side, you have x squared. Now, you can also just plug in 0 here, and you get 0. However, because these two are not equal, then the limit at that point does not exist. That does not satisfy all 3 conditions of what it means to be continuous, so therefore, not continuous. And lastly, use the intermediate value theorem to show that x cubed plus x minus 1 equals 0 has a solution between x equals 0 and x equals 1. We look at f of 0 and f of 1. F of 0 is equal to negative 1, and f of 1 is equal to 1. You can see that because of this sign change, there must be some value between 0 and 1 such that f of that value is equal to 0. So by IVT, there must be some c such that c is on the interval 0, 1, and f of c equals 0. So that concludes this video. And this video is actually the end of our first unit on limits. In the next video, we'll start on our next unit, which is derivatives. I hope you enjoyed this video, and I will see you next time.